Okay, so the two problems I just asked you to do, what did you notice about both of them?
No fraction bonus.
You had an x and a y, and where was the x and where was the y?
X was on the bottom.
X was in the bottom. These are called reciprocal functions, okay? These are called reciprocal functions. What you're going to see in today's assignment, you're going to see some number in the numerator, and that's going to be called your a value. You're going to have your x value is in the denominator. Sometimes there's going to be a number here, and sometimes there's going to be a number here. Sometimes there's not. There's always going to be an a value here. There's going to be a number here and a number here sometimes, or sometimes it's going to be a 0, okay? Now, do you remember when we did this function right here? Do you remember what that was called? Square root function. Do you remember what it looked like?
It was either
A rocket. How did we graph the parent function? We plugged in numbers like 1, 0, 1, 4, and 9, and we put 0 in here, we put 1 in here, we put 4 and 9. And when we graphed it, we saw that it looked like this rocket, right? Then what we did was we looked at stuff like these kind of problems. These are called transformations. What does it do? Do you remember what it does? Do you remember what this does right here? What does this do?
shifts it left or right.
It's
Right
going to
to-
shift it, how many units?
Right 2 units.
Right 2. Well, do you know what you do to your graph when you shift something right 2? You take your x values and do what to them?
Add 2.
You add 2. Do you remember what this number did right here? That was a vertical stretch by 3. Do you remember what you do to your t-chart with that?
Multiply y.
Multiply the y values by 3, and do you remember what this thing did?
It
Up or
moved
down?
it up 4 units, which is
And that you would add 4 to your y values, remember that? Well, guess what this is gonna do? This number under here is just like the number under the radical. So if you had a -2 here, it would shift your graph 2 units right. This number A is this right here. That's your vertical stretch or compression. And this is your up and down. Easy? Now, we need the basic shape. We need the parent function. So we need to start somewhere. So this is what we're going to do. We're going to look at, this is called the parent function. Y is equal to 1 over x. Now, once we establish the parent function, I'm going to show you the tricks on how to graph any other one. It's very easy. Okay, first of all, you need to know the name of this. This is your reciprocal function. Now, if we play around with a t-chart, and I stick numbers like -3, -2, -1, 0, 1, 2, and 3 into this t-chart. If I put a -3 here, y is -1/3. If I plug a -2 here, -1/2. If I plug a -1 in, you get -1. Now, what if I put a 0 here? What's 1 over 0?
0.
No,
undefined.
undefined. This is a danger zone. You can't, that's going to be an asymptote, which we'll talk about in a second. If you put a 1 here, 1 over 1 is 1. If you put a 2, you get 1/2 and 1/3. If you were to plot these points, this is going to be a branch, and this is going to be a branch. We call those branches. If you were to plot these points, over 3, down 1/3, over 2, down 1/2, down 1, And what's happening is it's getting closer and closer to the x-axis and to the y-axis, but it's not gonna cross. Why? Because you have these asymptotes that the branch gets closer and closer to but will not cross. Now, this is this branch right here. These points are this branch. This branch is going to be this right here. So, you're gonna have two asymptotes. In this problem, these two asymptotes, which we use as dotted lines, is the x-axis and the y-axis. Now, where are you gonna get these asymptotes at? Well, the two asymptotes are going to be found, right? So you could have any number up here. This number, the opposite of this number is gonna give you your x, your vertical asymptote. And this number right here, y equals 2, is gonna give you your horizontal asymptote. So when you go to graph this one, you're gonna draw a vertical line at 3. Your graph is gonna be shifted 3 units to the right. So you're gonna have a vertical asymptote here and a horizontal asymptote at 2. Like that. Now, when is it gonna be the x and y axis? If this is a 0 and this is a 0. So if I give you y equals 5 over x, there is no, these are both 0. So your asymptotes, your vertical asymptote is gonna be this line, x equals 0, and this line, y equals 0. Now the other thing we want to talk about is this vertical stretch or vertical compression. This is our A value. If this number is positive, your branches are going to be in quadrants 1 and 3. If it's negative, like if I gave you a -5, that's going to be a reflection over the x-axis, which is going to put you in quadrants 2 and 4. So, let me sum that up. If your A value is positive, this is a positive A value, you would be in, your branches are going to be in quadrant 1 and 3. If it's a negative, you would be in quadrants 2 and 4. So positive, 1 and 3, negative, 2 and 4. You gotta know that. Now, we have a domain and range we need to talk about. Can you tell me what the domain and range is? The domain is all of your x values except, what's this number right here? 0. X is all real numbers. You can write it like this. Domain is all real numbers except x cannot be 0. In your range, your y values, it's all real numbers, x cannot be, y cannot be 0. Okay? So, where are you going to get your domain and range? If I give you this problem, your domain is going to be all real numbers except x cannot be 3. In this one, your range is going to be all real numbers, y cannot be 2. So your domain and your range come from these vertical and horizontal asymptotes. That's going to be your vertical asymptote, the opposite of it, and that's going to be your horizontal asymptote. Okay? Now, how do you graph these? On the back is an explanation, but I'm going to show you a very, very easy way to do these. Check this out.
Hello?
Hello? So, can you tell me the two asymptotes for this? 0 and 0. X equals 0 and y equals 0. Can you tell me the two quadrants that we're gonna be in? Is it 1 and 3 or 2 and 4? 1 and 3. Watch how easy this is. The points, we are just sketching a graph of this. I don't care if you get real technical, but there's 4 points that I want to see on this graph, and I'm going to tell you what they are. 1, 3, 3, 1. So 1, 3. I'm going to make a chart here. I'm going to list them for you. 1, 3, 3, 1. Then -1, -3, and -3, -1. So, -3, -1, -1, -3. And you're done. What if I gave you y equals 4 over x? Where are your two asymptotes? 0 and 0. 1, 4, 4, 1. -1, -4, -4, -1. If this were a 5, your asymptotes are where? Here and here. X equals 0, y equals 0. Guess what 4 points you're going to have? 1, 5, 5, 1, and -1, -5, -5, -1. So as this number gets bigger, what's happening is your graph is being vertically stretched. So you would have, for your points here, you'd have 5, 1, 1, 5, -1, -5, and -5, -1. What if I gave you y equals -3 over x? How would you do this one? Yes.
It would be in the opposite,
Mm-hmm.
quadrants.
So what points would you have?
-1, -3.
1, -3, I heard? Is he right? Yep. Where else? 3, -1, good job. So those two. Where else? -1, 3. And -3, 1. There you go. Now watch this. Grand finale. So I'm going to give you this. What do you think you're going to do now? Where are your asymptotes? Where are your asymptotes, guys? X equals 2, right here. And y equals 4, right here. So x equals 2, that's going to be an asymptote, and y equals 4, that's an asymptote. Now, is this graph, do you see 4 regions? Do you see 4 quadrants? 1, 2, 3, 4. I want you to pretend like this is your origin now. So, because we're talking about transformations, right? So, can you tell me how to graph this now? So if we started here, what would we do? Go over 1 and up 3. And over 3. From here, go over 3 and up 1. Draw your graph. And for here, you'd go over 1, down 3, and over 3 down 1, and then draw your graph. And if this were a negative, I would be in these two quadrants. Is that easy? Pretty easy, right? Okay, so let's do this back page together. Oh, actually, let's look at these really quick. Problem 3, forgot to talk about that one. Just make sure, this is from your book, make sure you understand, you'll see it. Your vertical asymptote, make sure you see it, it's x equals -1, which is right there, and y equals -2 is your horizontal. And for this one, when the a value is 1, you're gonna go over 1, up 1, and draw your curve, and over, from here, go over 1, down 1, and draw your, it gets closer and closer to those asymptotes. And then this last one, don't look at the answers, look at this graph. Okay, this comes from the parent function is y equals 2 over x. Check out your asymptotes. Where are they, and how would you alter this equation to match this graph? So how many units? Check your scale out. These are going by what?
2.
2. What's this number right here?
3.
It's 3. So, well, it's actually -3, right? So where do I fit that into my equation? How does that fit, that vertical asymptote? What do I do? Does it affect this down here or here?
X plus 3.
Good job, x plus 3. Yep. And this is shifted how many units up?
4.
How many? 4?
Yeah.
So plus 4. So what answer is that one? Everybody?
A.
A is the correct answer. Okay, let's graph, we're gonna graph as many of these as we can quickly. So, give me the two asymptotes for y equals 5 over x. What are the two asymptotes? Draw them in. Here, x equals 0 and y equals 0. Okay, so x equals 0 and y equals 0 are your asymptotes. And at the bottom,
We don't have that.
you don't have this?
It's not that problem.
What does it say?
15
over
x.
Does anyone have y equals 5 over x?
I don't.
Okay, if you don't have it, write 5 over x. Just write 5 over x. We're gonna do, you have something though, right?
Yeah.
What does it say?
15 over
15 over
x.
x.
Make it 5 over x. I didn't wanna throw them out, I changed it, cause it was off the page. So 5 over x, how would you graph that? Yep, you're gonna go over 1, up 1, 2, 3, 4, 5, put a nice dot. Over 5, 1, 2, 3, 4, 5, put a nice dot, and draw your curve. You wanna get close, you're getting closer to the asymptotes but not crossing. Now, how do I do a perfect graph? What if I want more points? You would plug numbers like 2. If you put a 2 in here, what do you get? It's 2.5. So you could actually be more specific by plugging numbers in and making a table, okay? But you could be here forever doing these. Where's the other branch gonna be? Mm-hmm. Mm-hmm. Good job. Now, can you describe the domain?
All the numbers.
All real numbers, x can't be 0. All real numbers, y can't be 0. Now, what's different about b? And I'm sorry, for b, you should have -5 over x. And if you don't, cross out what you have and write -5 over x. Okay? Now, how should this differ?
B and 2 and 4.
Where are the branches gonna be?
2 and 4.
You're gonna be in quadrant 2 and 4. So it should look like this, over 1 up 1, 2, 3, 4, 5, over 1, 2, 3, 4, 5, and up 1, so it looks like this. And over 1, 1, 2, 3, down 5. So you look like that. And again, your domain is all real numbers except x can't be 0, and all real numbers, y can't be 0. Okay, flip to the back. Do you guys have A, you have 13, A is 2?
Yeah.
Okay, just identify, what does that 2 do? Is it a vertical stretch or a compression? So if you have this A is 2, that's a vertical stretch by a factor of 2. What about if it was 0.5? Vertical compression by a half. And this last one is a vertical compression by 3/4. Okay, now, do you guys have 18?
Yeah.
Libby, is that what you have right there? Y equals 1 over x? Okay. Do you know what VA stands for? Vertical asymptote. We're going to run through these. Your vertical asymptote is x equals 0. Your horizontal asymptote is y equals -3. Your domain is related to that vertical asymptote. It's all real numbers except x can't be 0. And your range is all real numbers. It's related to the horizontal asymptote. Y cannot be -3. Okay, I want to hear you guys. The next one, 19. What's your vertical asymptote?
0.
X equals 0. Don't forget x equals. What's your horizontal?
Y equals -3.
Y equals -3. What's your domain?
All the numbers, x can't equal 0.
Yep, and what's your range? All real numbers, y cannot be -3. Number 20. What's your vertical asymptote?
X equals 2.
X equals 2. What's your horizontal?
Y equals 5.
Y equals 5. All real numbers, x can't be 2. All real numbers, y can't be, come on,
5.
5. I want to hear you guys. 21. What's this one?
X equals 3.
X equals 3. Horizontal.
Y equals 4.
Y equals 4. What's your domain?
All real numbers except for
X can't be 3. All real numbers, y can't be 4. Good. Next one, 22. X equals -6. Y equals
-1.
-1. What's your domain?
All real numbers, x can equal -6.
All real numbers, y can't be
-1.
-1. Number 23.
X equals -1.
X equals -1.
Y equals -8.
Y equals -8.
All real numbers, x cannot be -1.
Yep. Next one.
X equals 0.
X equals 0. X equals 0. What else?
Y equals -2.
Y equals -2. All real numbers, x cannot be 0. All real numbers, y cannot be -2. 25.
X equals -5.
X equals -5.
Y equals -6.
Mhm. negative 6. Easy? Okay, now, I want you have this graph right here? I want you right now to graph for me, I know it says 21. I want you to graph this problem. Make sure everyone can do this. So-
Every point or?
Just the four, I want the two asymptotes. Can you tell me what the two asymptotes are? What is it? What is it?
3,
What is it?
3, 4.
X equals 3. And y equals 4. And then from there, what are you gonna do? From here, you're gonna go over 1 up 2, over 2 up 1, and draw your branch. And you're gonna go over 1 down 2, and over 2 down 1, and draw your branch. Easy? And I want you to graph that one. Y equals negative 3 over x minus 1 plus 2. What are your two asymptotes? X equals what? 1. That's one of them. What's the other one? 2, right? So is anyone lost on how to find the asymptotes? The opposite of this number gives you your vertical asymptote. This number gives you your horizontal asymptote. What do you do from there? What two quadrants are you in?
2 and 4.
Good job, 2 and 4. 2 and 4. So what are you gonna do from 2 to get to 2? From the origin, which is this spot right here, you're gonna go over 1, up 1, 2, 3, and over 1, 2, 3, up 1. So there's one branch. And how do you get the other branch?
Down 3.
Where?
Down
Where?
3.
From here, tell me, direct me to where to go from here.
3 to the right.
To the right 3, down 1. And over 1, down 3. Last 3 on this page. I'm going to give you your two asymptotes, and I want the A value to be 2 for all 3 of these. Can you give me the equation? What would the equation be? Y equals
2 over x equals, or just
Plus
x.
4.
Good job. 2 over x plus 4. Good. How about number 27?
2 over x plus 2 plus 3.
And the last one.
2 over
X
x
minus
minus
4.
4.
Good job. X minus 4, minus 8. Okay, we just got one assignment done. Okay? Now watch this. Here's your homework.
Still not gonna be.